All right, time to dive into deep learning with PyTorch. We're going deep with Deep Learning with PyTorch Step-by-Step by Daniel Voigtkadoy.
This book is perfect whether you're just starting with deep learning or you're already a pro.
So it's beginner friendly. I like it. Sometimes I feel like machine learning concepts are written in another language. Is this book really step-by-step?
Absolutely. The book starts with something you might know. Linear regression.
Linear regression. Okay. Sounds kind of familiar, but I'm sure it makes sense in the context of deep learning.
Totally. It's like the first thing you learn with neural networks. One input, one output, nice and simple. The book uses synthetic data for this, setting specific values for B and W, and even adds Gaussian noise.
Gaussian noise. Sounds complicated.
Not really. It's just to make the data more realistic. You know, real-world data isn't always perfect.
Ah, okay. So we're getting the model ready for the real world. I get it. But why PyTorch? What's so special?
That's the really cool part. PyTorch makes the whole process so much easier and fast. But we'll get into all that right after the break.
Okay, so PyTorch it is. But how does it actually work? We've got this linear regression problem. Where do we even start?
Well, with gradient descent, of course. That's how the model learns.
Right. Gradient descent. I always think of it like trying to find your way down a mountain in the fog.
Perfect analogy. You can only see a few feet ahead, and you need to find the quickest way down. That's what gradient descent does. It figures out the best direction to change those parameters, the B and W we talked about, to get us to the lowest point where the model's predictions are the most accurate.
So we're trying to avoid those wrong turns, those uphill climbs that take us further away from the solution.
Exactly. And the size of our steps matters too. That's the learning rate. Big steps might get us there faster, but we risk overshooting the best solution. Small steps are more cautious, but might take a while.
Makes sense. So how does PyTorch help us navigate this foggy mountain?
2 words: tensors and autograd.
Okay, those sound like characters from a sci-fi movie. Break it down for me.
So tensors are like the building blocks in PyTorch. Think of them as souped-up arrays.
Souped up how?
They can handle tons of data and calculations way faster than regular arrays. And the best part, they can run on GPUs.
Whoa, GPUs. Like
They're-
what gamers use.
You got it. That means we can train our models way faster, which is a huge plus, especially when you start working with larger data sets.
That's awesome. But what about those gradient calculations? Aren't those super complicated?
That's where autograd comes in. It's like PyTorch's secret weapon. It keeps track of every calculation we do, creating this sort of map of the entire process.
So we can see every step the model takes, every decision it makes.
Exactly. And with that map, PyTorch can automatically calculate the gradients for us. It's like magic. No more manual calculation.
That is some serious magic.
Yeah.
I'm loving how PyTorch is taking care of all the complicated stuff behind the scenes.
Yeah.
So we've got our tensors for speed and autograd for, well, auto-calculating gradients.
What's next? Okay, this is blowing my mind. Tensors, autograd, PyTorch sounds like a dream come true, but how do we actually use all of this to build a model? It all comes together in the model class. We're talking about a Python class that inherits from n.module.
And module, what's that?
Think of it like the foundation for our PyTorch model, giving us all these tools and structures.
So we're not just writing code, we're actually building something with, like, real structure.
Yeah. And inside this class, we've got the init method, where we define all the parts of our model, the layers, activation functions, all that good stuff.
And what about the forward method I've heard so much about?
Ah, yes. That's where we tell PyTorch how data flows through the model, like setting up an assembly line.
Love that analogy.
Yeah,
So the data comes in, gets processed by each layer, and then boom, we get our output.
exactly. But before we hit go, remember those parameter updates and loss functions? PyTorch has some tricks up its sleeve for those too.
Oh yeah. Those always seemed kind of like the behind-the-scenes math that I never fully understood.
Well, PyTorch takes care of a lot of that for us.
Yeah.
For those parameter updates, we have optimizers. They're like little helpers that automatically adjust the model's parameters to minimize the errors.
So they do all the heavy lifting.
Pretty much. And as for the loss function, PyTorch has a whole bunch of built-in ones, like NMSE loss for mean squared error, which sounds scarier than it is.
Okay, I'm following. So PyTorch is handling the parameter updates and the loss calculations. It's like it's doing all the hard work for us.
Exactly. It really simplifies the whole training process. In the book, they break it down into 3 main steps: data preparation, model configuration, and then the actual training loop.
Data prep. Got it. That makes sense.
Yeah.
We need to make sure our data is in a format PyTorch can understand.
Right. Then there's model configuration, where we create an instance of our model, define the loss function, and set up the optimizer.
And we're getting all our tools and ingredients ready. And then the training loop.
Yep, that's where the magic happens. We feed our data to the model. It makes predictions. We calculate the loss. PyTorch automatically computes the gradients. And then the optimizer updates the model's parameters based on all of that.
Wow, it's like a perfectly choreographed dance. And PyTorch is the choreographer.
Exactly. It orchestrates the whole thing, making sure everything runs smoothly and efficiently.
This deep dive has been incredible. I feel like I've gone from zero to deep learning hero in just a few minutes.
And we've just scratched the surface. There's so much more to explore, different model architectures, more complex data sets, fine-tuning those hyperparameters.
It's amazing how PyTorch makes it all feel approachable, even exciting. So, to our listeners, if you're ready to dive into the world of deep learning, PyTorch is your new best friend.
Absolutely. Don't be intimidated. Just grab the book, fire up PyTorch, and start experiment.
You heard it here first. And until next time, happy coding.